Greetings folks and welcome to the Electromaker podcast. This is your roundup of all things maker and embedded and lovely, albeit in audio format. If you're tuning in for the first time, this is a YouTube show that I put out every week for Electromaker on their YouTube channel. But it works quite well as a podcast as well, I have been told, because I'm definitely guilty of waffling so much that the visual is not necessary. On this week's show, we'll be looking at a couple of new products. There is a new compute module type board from LattePanda, and the exciting thing about it being it is x86. And as someone who receives a bit of flack every now and again when I say that x86 single board computers are worth having, the argument being that you can just get a second-hand Intel NUC or mini PC for much cheaper, that'll be much more powerful. I feel like this is a definitive step away from that and into territory where it really is quite a unique idea, because there are such a wide variety of baseboards that you could get for this. And again, if you follow the link in the show notes, everything I talk about today is linked in the show notes, you will see there are many mock-ups for different potential designs for these carrier boards, and already one larger motherboard type affair is available and a lighter version which is a bit smaller, which puts it in a more Raspberry Pi territory size. We'll also be talking about a new Nordic product, mostly because I messed it up last time I talked about it. At least on the YouTube show, because the last podcast, of course, was interviews, it was different to the YouTube show. I referred to the NRF 9161 as the old cellular system in package from Nordic Semiconductor, when in fact it was released only at the start of this year. So we'll be going back and looking at the changes for that and the new development kit, and the reasons why you might want to upgrade if you are working in cellular IoT. We'll also be having a quick update of Hardware Pioneers, the upcoming conference in London. We are giving away a Raspberry Pi 5 as our product of the week. And also, I have been going down the rabbit hole of learning AVR assembly for no good reason whatsoever. And so I'll be giving you some tips as to where you can look for a nice and well-paced tutorial for that if you are interested. So with all of that to get through, let's get on with this week's podcast. Up next, we're going to talk about the LattePanda Mu, the latest in the line of x86 boards released by LattePanda. But there is a noted difference here. We talked about the LattePanda Sigma, which was billed as a single board server, but it was a single board computer. We talked about the Delta. We've also talked about the Alpha. All of these are single board computers, albeit x86 single board computers that can run Windows or Linux natively, that also have GPIO pins for working with input and output, thanks to the built-in ATmega 32U4 chip, which is the same one you find in the Arduino Leonardo and Micro. This time, things are somewhat different. The concept of a system on module is something we're very used to these days. ESP32s are systems on modules, for example. But my first experience of it was actually with the old NVIDIA Jetson Nanos when they were first released some years ago. The board itself is just a baseboard, and the system on module can attach onto it. This one's actually screwed onto there, so I can't pop it off right now. But you're getting an idea as to the size of the system on module. It's very, very small, and as is the LattePanda Mu, but with one large difference. It is x86. But as the product page on LattePanda.com says, it is card size, fits somewhere. Albeit it is smaller than a credit card, although probably slightly wider, so it wouldn't fit in your wallet, but it would fit somewhere. But all jokes aside, this is a really interesting product because this is a really tiny x86 single board computer, but it packs a fair bit of power. It has an Intel N100 quad-core processor. This is an Adler Lake processor. It goes up to 3.4 gigahertz with 6 megabytes of cache, and it also has built-in graphics, 8 gigabytes of memory, and it also comes with a 64 gigabyte eMMC flash on board, alongside this edge connector here. But that's not all. It has a lot of input and output on it that is very highly customizable, which means that this is something that could slot into a lot of designs, something they've already started to think about, which we'll get onto in a moment. So there's a nice little chart on the page here that sort of gives an idea as to how flexible this can be. I don't know whether this is meant to be clickable or not, but either way you can see it has 3 PCI 3 lanes, and they are configurable to work in different ways. There are also 4 I2C outputs, 2 UARTs, there are 8 USB 2 ports, and expandable up to 64 general purpose inputs and outputs. And the reason for this is that you can do a huge amount of different things with it. If you look down here, they have some mock-ups of different baseboards you could use. This is a NAS carrier that allows you to add a bunch of NVMe SSD drives on the side, or a router carrier carrier designed for using this as a router with a bunch of Ethernet input and output, a bunch of network throughput. Also a graphics one, which is designed to work with a frankly chunky looking GPU compared to the tiny little board here. But then again, thinking about it, if that's credit card size, maybe this is also quite a dinky GPU. So before we go any further, the main thing that people always say to me when I show anything x86, be it a single board computer or this new idea of using a system on module, which is x86, and I'm not saying LattePanda are the first ever to do this, but I can't bring another system on module with an edge connector to mine that is x86. A lot of people say, why don't you just get a cheap secondhand or mini PC of any kind that will do all of this anyway? And go for it. If you don't need the GPIO, if you don't need the form factor, you should absolutely do that. But this thing isn't priced too crazily either. So the system on module itself sells for $190, and there are a bunch of different baseboards that you can get. The full function evaluation carrier board is a further $89, which basically turns this into sort of like a mini ATX or ITX motherboard. If I open both of these up, I haven't actually looked at the dimensions of this one yet. I know the light carrier board is a bit smaller and actually makes it come out at about the same size as your regular SBC size. Not exactly the same size as a Raspberry Pi, but pretty small. The light version still exposes a bunch of stuff. You still get your HDMI out, you get your networking, your USB. You still have your PCIe slot here for slotting in whatever you want to. Again, you could slot your chunky video card in there if it will fit and if it will get enough adequate power. That is stuff you'll have to work out ahead of time. And then the full function EVA carrier board here pretty much exposes everything that the Mu can do. And again, if you don't need this, then you could just get a normal motherboard and build a desktop out of it. But the whole idea of this is that it can be used for a huge amount of different things. Rather than seeing this as a single board computer that could be replaced by a mini PC, see it as, well, I really like this. See it as something like this. A little SODIMM thing that you can slot into a big board like that and spend time working on an x86 cluster design like this. And then you can pop that very same thing out and work on an entirely different project by just changing the baseboard that you are using. It seems like a very powerful idea. I'd be very interested to see if you agree with me on that. I tend to be very positive about these new designs and new ideas. There are many people that are very quick to point out that sometimes I get too enthusiastic about it, but in this case, I think LattePanda may be onto something. Just dropping in very briefly to remind you that the Electromaker Show is funded entirely by the Electromaker online store. If you are looking for something for a hobby project or maybe 10,000 of something for your job, or indeed many of the things in this show, we have Raspberry Pi 5s in stock, we have the Nordic semiconductor, NRF 9161 in stock, and a massive range of other things, including things from Adafruit, Sparkfun, and a bunch of other suppliers, as well as actual brand names. So yes, if you are interested in that, head to electromaker.io/shop. And if you are listening to this on some kind of podcast app that allows ratings, giving us a 5-star rating and maybe leaving a little review talking about how much you enjoy the show would be handy as well, just as it might help bump us up a little bit in the podcast ratings, although none of this, of course, is mandatory. Anyway, back to the podcast. It is time for our product of the week, and that product is the Raspberry Pi 5, which I know is one many of you have been waiting for. Now, I have said pretty much since the Raspberry Pi 5 was released that I think this is a really significant update to the Raspberry Pi line, not just because of the power increase, but because of the RP1 custom silicon taking care of all the GPIO inputs and outputs and doing nice things like letting you use 2 cameras and 2 displays instead of 1 of each, and the fact that it has the FPC connector on it, opening it up to PCIe. I was running out of words there. Meaning you can attach GPUs to it or NVMe SSD drives. And in fact, while we're talking about that, we'll get to the article and video from Robin in a moment. On our blog, right next to each other are the Raspberry Pi display that I saw at Embedded World, which was connected to a Raspberry Pi 5 with an official NVMe Raspberry Pi 5 FPC connector hat. And it was a hat because it was on the top, but they can also fold underneath. So I suppose there could be FPC connected boot boards as well, you could call them. But right next to that is Pineberry Pi, a really interesting 2-person company who we got chatting to at Embedded World, who have put out a plethora of connecting boards to the Raspberry Pi 5 already. The one you can see in the image here is a Hi-Fi DAC, which works with Pineberry Pi is the name of them. The Hi-Fi Berry DAC is compatible with that software. They also have a range of different hats for different M key slotted things and networking. So they have an Ethernet hat, which is more powerful than the onboard Ethernet from the Pi 5. I can't remember the numbers. And also a hat for SSDs, a hat for a Google Coral TPU plugin as well. So that's all stuff that's definitely worth looking at. I'll link I may as well just link the blog in the description because they're right next to each other here. So moving on to the Raspberry Pi 5 product of the week. So moving on to Robin's article and video. I always end up saying this, that Robin is an engineer who really knows what he's talking about, so you should listen to him instead of me. But chatting with Robin at Embedded World really made me realize that he is someone that knows what he's talking about, as comfortable working with a PIC in assembly code, as setting up a quite complex home networking. Robin really does know his stuff. And the videos are entertaining. If you haven't watched any of the Product of the Week ones, yeah, they're also quite funny too, so it's definitely worth taking a look at. And of course, there is the blog that takes you through everything you need to know too. This is an interesting one because I feel like most of the information about the Pi 5 is stuff that you will already know, whereas a lot of the other Product of the Weeks are products that you maybe wouldn't have come across before anyway. But yes, I've said my piece about the Pi 5. I am thoroughly enjoying using mine, albeit in headless mode. I haven't even pushed it close to its limits yet. I'm really looking forward to attaching things to that interface. In fact, Pineberry Pi make exactly the kind of thing I'm looking for, because the NVMe drive plus Google TPU hat is something that I find very interesting, because I love the idea of small SBCs that are capable of a modicum of AI processing for a secret project that I'm working on. Anyway, this is the link to the video and blog post, which will be linked in the video description, of course. But this is a product of the week, which can only mean one thing. If you would like to win a Raspberry Pi 5, all you need to do is be a subscriber to this channel and leave a comment on this video saying what you would do if you won it. What is your dream Raspberry Pi 5 project? Is this your first single board computer and you're learning? I want to know. However, you also need to leave the hashtag Pi5, hashtag Pi5, no spaces, because we gather all of the hashtags together and then we choose a winner at random, which is just the fairest way to do it. And we'll be announcing the winner of that competition in the next couple of weeks. And anyone who does win those competitions, by the way, whatever you come up with, I would love it if you put it up on our Electromaker project hub. It always makes us very happy to see projects from people who have actually received hardware from us. And it happened recently with the Firebeetle 2 ESP32 board. Maybe the next show that we have after you get your Raspberry Pi 5 could feature the project that you do on it. We are getting closer to Hardware Pioneers, which, if you're not familiar with it, is one of the best embedded conferences in the UK. It's amazing, really, how Hardware Pioneers has gone from strength to strength, because if what seems like a few short years ago, it was a few people meeting to have pizzas and chat about cool embedded projects and hardware and what they were working on, it has now grown into one of the best conferences that you will find in Europe for this, and certainly one of the best ones in the UK. And the thing that I like about it is that the interviews that we've done over the years there, because Robin and Rich, who are based in the UK, have been several times and interviewed a huge variety of people. They do cover names that you will know well. Robin interviewed Massimo Banzi there. We've interviewed people from NXP, from Sony, from big names that you know, but also from some smaller companies who I hadn't heard of, and even companies pushing technologies that I had never previously been aware of. And so, yeah, there's a lot of really interesting interviews. There's blog posts covering all of those. And if you'd like to find out things that have been in the previous years, you can just search Hardware Pioneers on our blog. Now, the price goes up and up as it gets closer to it. So if it is an event that you think you would like to attend, it is the 28th and 29th of May in London, and you can get tickets from the Hardware Pioneers page, which I will leave in the description. There is also an update. This is actually a newsletter that they sent out, but I have a link to it as well. You can, of course, sign up to their newsletter on the website, but this is the latest newsletter that gives you a little bit more of a taste as to what will actually be happening on the day. So alongside some of the media partners and a special focus on IoT antennas here, I think a lot of people will probably be interested in seeing the full exhibitor list. And if you follow the link out of this letter, which I will also be linking, you can find the full exhibitor list here. I am unfortunately not going to be able to come to Hardware Pioneers this year. I was really excited about the concept of maybe coming over, but yes, I have a clash, and unfortunately living in a different country with a family and small children in it, it's very difficult for me to drop everything and go to things. However, I was very lucky to have just gone to Embedded World, which is a big version of this that happens here in Germany anyway. But if you would like to find out more about it, there are links to the Hardware Pioneers website and also the letter that I've just talked about here, the newsletter. You will find links to both of those in the description. If you are UK based and are thinking of coming along, please do let us know either in the comments on YouTube or in our Discord server. You can find an invite link in the description here. We would love to meet you and say hello. I won't be there, but other people from Electromaker will, and it's always fun to meet people at conferences. There is a certain mystique to bare metal programming, the idea of getting as close to the device as possible, understanding what all of the registers are doing, and making your code in C or maybe even assembly do exactly what you want it to without any abstraction whatsoever. But there is also a very strong argument to say that most people these days, especially hobbyists, don't really need to know any of that stuff. And I mean, the Arduino is the classic case of this. You've taken the ATmega 328P, which isn't the most complex chip in the world, but certainly one that I could not program simply by reading the datasheet alone, and turned it into something that has its own programming language that's easy to understand, that's very similar to another well-known programming language, C++, that can compile and flash with the click of a couple of buttons, and you don't need to know what's going on here. You can learn circuitry and programming at the same time without really knowing anything about the internals of what's going on. And this is fundamentally a good thing. But what if, despite there being no reason for you to actually need to, you want to know what's going on inside and you want to learn how to program it in the most low-level way possible? Well, luckily for me, there are some fantastic tutorials out there, and I'd like to share one of them with you. Now, I am very aware that I've been talking about learning Zephyr for the last 6 months, which is like the hardest of abstraction layers. And now I've got jumped right to the other end. And I should probably relax and just do a nice, simple MicroPython project with a Raspberry Pi Pico. But no, I have been spending the last few days getting my head around AVR assembly and the ATmega 328P. And 1007, who I'm just going to call 107 to make it simpler, has put together a wonderful set of tutorials on Instructables that I will link in the description. I'm going to try and keep this brief because I could waffle about it for ages, but the pacing of these tutorials is wonderful. It takes you through what's happening with the chip, what's happening with the assembly code. It helps you understand every step of it and gives you challenges and questions to maybe change a few things, break them, and work out why it's broken. That's very much the idea of this tutorial. Don't just do as I say, mess around, play with this. And the time and the pacing of it is really slow. For example, tutorial 1 just tells you how to turn the onboard LED on. That's it. No blinking, just turn it on. And the beauty of it is that it's a simple process, but you learn every aspect of how it works. You learn that digital pin 13 on an Arduino Uno is PB5, which is the 5th pin on port B. You learn how to actually program that in assembly. But before you learn this, you learn that you need an assembler. And there is a very simple one called Avra if you are on Linux. Literally, you just say Avra and your file, and it'll spit out a hex file. You'll also learn that you need to put that file onto the board. When you click the upload button in the Arduino IDE, it runs a program called AVRDude in the background, which will put that into the right spot in the flash memory of your MCU. This is all stuff that are prerequisites, but the beauty of it is that it says, okay, so here's the program, let's understand it. Let's understand what is register 16. Why are we putting this binary number into it? What happens when we put that binary number into the direction register? What happens when we put it into port B? If we just have 1, 1 and the rest of them are zeros, does that mean that the entirety of port B is on, or does it mean that just the one where we put the 1 in, the 1 bit, is on, PB5, which happens to be digital pin 13? Well, it certainly looks so because the LED is on. There are a number of other things I like about this tutorial series. Like I say, there are exercises and questions, this idea, oh yeah, break stuff, try stuff out, but also things like this. There's a lot of things like the include file, and all of the code is really well commented. And in the third tutorial, when you're learning about timers and how to actually make it blink, it says, why do we need the comments and the definition file? And then shows you what the binary would look like without it. Sorry, the assembly would look like without it. And again, this makes it very easy to understand exactly what's going on here, because you realize, oh, okay, so these are just definitions of all of these numbers on the board, and this is exactly what the board needs to know. These numbers need to all be put in the right place and in the right registers in order for the chip to understand what you want it to do. And all this is the first level of abstraction. You're giving them names that are easy to understand. Anyway, to people who are old hat in assembly, this is probably not all that interesting, but to people like me who never learnt that stuff and are going back to learn it now, this is a real treasure trove. Later tutorials show you how to do input, how to do various things to do with timers, pulse width modulation, and also how to deal with the fact that you only have a certain number of registers and might want to do more things than you have registers for, so how do you deal with that? If you are on Windows and you want a simple assembler, I highly recommend AVR ASM2. It is the one that ships with Atmel's Studio. If you want to use it on the command line, I would suggest seeking out an AVR ASM2 download. There are various places that you can find it. Some of you might find this horrifying, the idea of just downloading a random link from a forum. I have been using the zip version that Brian Fairchild put up on the AVR Freaks forum back in 2021. I have virus Iris checked it, and I am fairly comfortable that Brian Fairchild is not performing Trojan attacks on my computer. But yes, your mileage may vary. However, this is just the assembly file itself, and the first tutorial here has the include file, which should be everything you need to get started. So in the Electromaker Show about Embedded World, I talked a little bit about the new products on display at the Nordic stand. We also did some interviews with the Nordic staff, by the way, in case you missed that. They're available on our YouTube channel. There's also blog posts about 3 of the demos that Nordic showed us there. But when we were just sort of nosing about and looking at things, I noticed a few new things, like, for example, the Thingy 91X, which has a new system and package inside it, the NRF 9151. And I believe I talked a little bit about that system and package on that show, saying it was a big step up from the NRF 9161, which is an error. The NRF 9161 is also a new system in package in a slightly larger form factor, but it is an upgrade from the NRF 9160, which we've talked about for a while. That was Nordic's flagship system in package for cellular IoT. I know that's a lot of number designations and all that kind of stuff, but let's just have a quick look at the NRF 9161 and the big differences it brought when it was launched at the start of the year. So the NRF 9161 is the follow-up to the NRF 9160 system in package, and the NRF 9161 was made available at the start of this year. I'm just going to refer to this as the 61, just to keep things simple, because NRF 9161 is quite a long thing to say. But the NRF 9160 is the older one that we talked about. We have a review on our blog, and that's not going anywhere, by the way. There is I can't remember where I read this. It might be in this thing on the dev zone, which we'll get to in a moment. But the NRF 9160 is going to continue being made for as long as people want it, according to Martin Lasund from Nordic Semiconductor. The NRF 9161 adds a couple of nice features, though. So let's start by just looking at the press release that they put out. So you can get the development kit for it, and I will be leaving a link in the description, as well as the product page on Nordic. I will leave a purchase link for it, just in case you want to get your hand on one of the development kits after hearing this. But in short, it is, well, a fully integrated, pre-certified system and package supporting 3GPP release 14, and it is the first device in the NRF 91 series to support DECT NR+, a revolutionary non-cellular 5G technology. Now, it is out of scope for me to go into the history of DECT and why NR Plus is different, but luckily I do not need to. Another thing I'll be leaving a link to is the DECT forum here, and it talks about the new standard, the new DECT standard NR Plus, and it talks about the introduction of it. And there are even a series of webinars all about NR Plus that go through it in real detail. They're from a while ago now, well, only 1 year ago actually. For some reason I thought it was 2 years ago. Anyway, this goes through the history of DECT. And by the way, I'm not someone who's very knowledgeable about this. About all I know about DECT is that when it appeared in the early 90s, I mean, I think it was the late 80s that kind of started. All I know about it is it started sort of in the early 90s. It was only a thing in Europe at first. And I only know about DECT because it was the way that the first wireless phones worked, as in your wireless landline phone. You'd have the base, and then you'd have your wireless phone that you walked around with. And DECT technology is what allowed you to have several different handsets around different parts of the house, all linked to one base that was plugged into the wall. But of course, DECT has been evolving since then, and now DECT NR Plus seems like a very exciting thing. There's one specific sentence here which I thought was very useful. Yes, so the NR Plus announcement on the DECT forum has a frequently asked questions link on the side. I'll link this page in the description. You just need to click here to get to the frequently asked questions. There's a lot of information here, but the one that jumped out to me is the question, how does it compare to 2.4 gigahertz connections like Bluetooth Low Energy? Given that DECT NR runs on a lower frequency band, in the 1.9 gigahertz DECT band, there's much less congestion. The standard utilizes well, I should just read this from the start, shouldn't I? As a rule of thumb, the DECT NR Plus standard has a better range and throughput than Bluetooth Low Energy. In the 1.9 gigahertz DECT band, there is much less congestion than on the Bluetooth Low Energy 2.4 gigahertz ISM band. DECT NR Plus for machine control is a logical use case. So the idea here being that you could use this for wireless communications in environments that might be quite busy and still have a strong signal and a faster throughput. However, me saying that confidently should not fool you. I do not really know what I'm talking about when it comes to DECT. I do not really know much about cellular IoT beyond sending data to the cloud, but I do know that my experience with the previous version of this chip, the NRF9160, was pretty painless. The development kit came with a SIM card, which worked globally, I think, but where I was in Europe, it was no problem. I plugged it in, and I had it talking to the NRF cloud within minutes, sending sample data to there. And of course, from there, this is all Zephyr based. So you have a bunch of modules that are already designed to work with Zephyr that you can plug into your development board and get going with, and a bunch of example code as well. And as I've said many times before, Zephyr has one hell of a learning curve, but once you get over the very, very first part of it, even if you're not ready to do your own device configuration at that point, you can pretty much evaluate any aspect of any project because all of the configurations are the same, equally complex. So if you would like a brief rundown of the differences between the two NRF91 flagship processors, that is the 61 and the 60, there is a fantastic post in the Nordic Dev Zone, which is their forum. Someone asked the question, we're starting a new design that requires this chip. These are the two main differences they see. And then Martin Lesund from Nordic has come in with a full table of the differences, which funnily enough, we have seen before, because seeing this jogged my memory. Way back in January, before they had announced the Thingy 91X, I mentioned that I'd seen it in a chart, so I knew it was coming, and this is the very same chart. So we've actually looked at this before on the show, but now we're looking at a little more information. So the DECT NR Plus is the thing I've just talked about. If you'd like to know more about that, there's a full slew of webinars about it here, which I have not had the time to go. I've watched about half of the first one, and they are wonderfully detailed, and I'm really looking forward to getting through them all slowly. But yes, the other thing that is a big difference is 3GPP Release 14. Now, I've read up on this a little bit from a very high level, and if I had to put it into a sentence, Release 13 basically kicked off the whole idea of NB-IoT and LTE-M, which is the way of sending small amounts of data and not using that much power. Release 14 essentially means you can send more data with even less power. It's just made everything even more efficient. I am very much not covering the entire story there, but that's all that really matters in this instance, I think. You're getting more with more efficiency, which is probably a good reason to consider getting the NRF9161, because you're going to be getting more battery life out of your IoT devices. And with cellular IoT, that's the name of the game, really, isn't it? So, if you would like to know the differences between all of them, there is also the NRF9131 on here, which we haven't even talked about yet. We'll get onto that one at some point in the future. You can see here, but the main difference being the 31 doesn't come in a system in package, so I'm assuming that is a standalone module or something. We'll get into that when we do. Future Ian here. I'm not quite sure what I was saying in this particular moment, given that on screen there is not an X next to system in package, but right underneath it, where it says mini system in package, there is an X, which is exactly what the NRF9131 is. It is very much the same idea as the NRF9161, yet it comes in a much smaller package. Yet, as I said in the show, we will actually go into it in detail at some point in the future. But yes, the NRF9161 has DECT NR Plus, as we've said. It has some more certified bands. It adds band 85. I could have sworn it said it added band 65 somewhere as well, which is another global band. Maybe I misread that, or maybe there's a mistyping here. But either way, it adds band 85, which is the West NAR. I can never remember exactly what that stands for, but it covers a large amount of China. And then obviously you have a new frequency range, NR+, which we've just discussed, which is slightly below the Bluetooth low energy range, but with a faster transfer rate and with less interference, and a few other things as well. Like we mentioned, the 91X will be coming soon, which looks like a lot of fun. As I mentioned, the 91X doesn't just add this new system in package, it also adds the Wi-Fi IC, so you get Wi-Fi 6 on it as well. Very excited for that one. Anyway, I have probably talked about this for longer than I meant to. I just went a little bit down the rabbit hole, trying to find out a little bit more about things that I do not understand, and that's one of the things I love so much about this show, that I get to do deep dives on all of this hardware that is in many ways above my pay grade as a hobbyist, but I hope I've given you a nice high-level overview, and if it is something you're interested in, the information you need to find out about it will be in the description of this video. And if you are planning to start a cellular IoT design, and you think this is a good board or a good system in package, or even a bad system in package for your use case, I would love to know why. Let me know in the comment section below. That was our show for this week. Thank you so much for joining me. Thank you for your continued support. If you are wanting to get in touch with us, you can contact me directly at ian@electromaker.io. However, if you join our Discord server, a link for which you can find in the show notes, it's a little bit more visible to me and the rest of the Electromaker crew. One of the issues of being a semi-public facing person is that my official email inbox is absolutely full of many well-meaning offers from companies, so much so that I have in the past missed the odd email sent to me from people who actually listen to the show, which is a real shame. So I would advise the Discord server. However, if you do email me at ian@electromaker.io, I will get it. It just might be a little later than I expected. I hope you enjoyed this show. I'm always open to feedback about things you'd like to hear more of, things you'd like to hear less of, and if there's anything in particular that I talk about very briefly that you'd like to hear more about. I don't cover 3D printing all that much, but I'd be happy to cover it a bit more if it's something that there is interest for. Anyway, with all of that said, I hope you have a fun, safe, and creative week, and I'll be back to chat to you very soon.